From Solid Social Security, and I'm back with another video. But the past probably about I think it's like 7 or 9 videos that I've released have all been based around building an HTTP server and FTP server and Python, and it's still ongoing. I'm still working on some things. So you see this video posted and you're freaking out going, well, what's going to happen next? There's so much more that I want to know about HTTP and FTP servers. Well, don't worry about that. I'm just kind of doing this video to kind of like take a break from that. And basically, going to open this up for a new series I'm also going to work on, over time that I'm going to make videos for is programming theory and design. The purpose behind this little series is to introduce essentially what programming is, what programming can do, the theory and design behind it. So let's start off with some basic little facts, a little bit of history about programming and the development of programming. As you can see, I got a lot of crap, so I can find. Here we go. Text edit. No, don't want anything on the cloud right now. Alright, so first video in programming theory and design, go over a little bit of history and essentially what programming is. And also plan to throw another little video with this that I'm going to try and attach to once I pull up iMovie and all that, but we'll get to that when that comes here. Alright, first person I want to talk about is Francis Bacon. In 1605, he kind of like theorized a system of taking letters of the alphabet and reduce them to sequences of binary digits. So a little while later, I think it was like 70 to 100 years later, maybe even 200 years later, a man came along named, let's see if I can spell his name right, Godfrey GE. Yeah, I had to write down these names next to me so that way I can get the idea. Alright, he actually came up with the concept of the binary. He basically took what Francis Bacon said and kind of actually came up with something, because Francis Bacon just said, what if we had this idea where we take letters and we kind of like make them into numbers? And our friend Godfrey here actually did it. It's the 1 and 0 system. We also call it the binary system. And I'm going to tackle the binary system in a few minutes. That's actually what the main part of this video is going to be about. But first I'm going to tackle a few other people and an event or two. First person I want to, after the invention of the binary system of 1 and 0, I want to talk about Ada Lovelace. There's a programming language named after her, but one of the most important things to know about her is she is recognized as the first computer programmer. And probably should have brought this up before. Another person that we are gonna bring up, hope I spelled his right too, was don't really know how to pronounce it, but we'll just say Mr. Loom. In 1801, he invented a punch card system to represent sewing looms. He this not 1901, my bad, 1801. I should have probably put him back here. Probably should have talked about him first. Alright, the punch card system in a way was kind of like the first way of programming a machine per se, is taking a punch card and punching holes in certain areas, and it kind of like designs the layout in the looming machines. So this is like the first way of programming a computer, but Ada Lovelace is still credited as the first computer programmer, which I find actually kind of funny considering computer programming is a male-dominated field, but yet the first computer programmer recognized is a female. So go women. And I didn't I forgot to add this name in my notes, but we'll get to him in a second. So we have this binary system, which is rather primitive, but in the 1940s we had the assembly language come around, not assembly language, assembly languages. The assembly languages are once again kind of rather primitive. They are very, very powerful, and the thing behind assembly languages, yes, they have, they're pretty powerful, they do what they need to do, but the problem is there's a great deal of you need a great deal of intellectual effort to be able to program in assembly, from everybody I talked to and what I've read, and also it is error prone. Now I'm going to jump a little bit ahead, and I'm going to talk about, don't mean to say anything bad about programming languages developed in the 60s, but in the 60s we had great programming languages come up, such as Fortran, I believe, COBOL, Lisp. But really, kind of the programming language that takes the crown as far as early programming goes is one of the most popular programming languages in the world still to this day, which is used to code operating systems such as Linux, Mac OS, Windows, is the C programming language. And it was created by Dennis Richet. There may be a T in there, I'm not exactly sure. He worked at I believe he worked at Bell Labs during the time, and he came up with the C language. And he had a good friend who also worked in Bell Labs who created the UNIX operating system, in which C is a good example of how versatile and how powerful the language is, and the fact that it was able to create a whole operating system, just one unlike any other, because Unix at the time was considered very advanced. People load up Unix now. Unix is a great operating system, but if people load it up now, which there's not really anybody running Unix, they run, right now there'd be people running flavors, or I guess you could say like flavors of Unix. It's not Unix, but it's Unix like operating systems like Linux, BSD, Mac OS, and Unix just kind of showed how powerful this language was. And the point of Unix was to be able to take, because at the time there were tons of different operating systems meant for tons of different purposes. Unix was meant to kind of take all that, like erase all of the specialized operating systems, and to be able to give the user one operating system that can do everything that they need. And the C programming language helped this out. And so C basically revolutionized the way that we looked at operating systems too, and a bunch of other different things. So I'm going to get off talking about C and bragging about C. Now, I'm not much of a C programmer, unfortunately, because I kind of like Python, but C is very, very important. And also, I guess you can say a fun fact, the same day Steve Jobs died, the founder of Apple, is the day that the inventor of the C programming language died. And unfortunately, I thought it was kind of wrong that Steve Jobs got more media attention than the guy who, if it wasn't for Dennis Richet, Apple, Windows, these companies probably wouldn't be around. So I'm going to get off that, and I'm going to talk about the binary system. Now, whenever you talk to computer programmers in computer science, they may call it binary system. Another term you'll hear for it is called machine language. And basically what it is a series of 1 and 0s. Didn't mean to put an N in there. That is essentially what binary would look like, except, probably not the right format and everything. But simply what it means is 1 is on and 0 is off. Whenever you think about the concept of computing, people seem to have this grand idea that are look at a computer that's such a complex machine. When truly, if you actually break down a computer, it's very, very simple technology. For instance, a hard drive, you take it apart, there's an actuator arm, and it just simply writes, like literally writes to a silver disk, or it writes to a disk information in a format. Well, how a computer does all of this is through a machine language binary system, and it's basically, think of a computer as switches. You throw switches for everything, and I'm going to show a little bit of an example in this after I finish explaining this towards the end of the video. I'm going to use my phone, get a little video of me showing an example of switches and how to think about this. So think about a computer as a series of switches. You turn a switch on, you turn certain switches on, you turn certain switches off, and it gives you this kind of it just gives you this kind of like effect. If you turn certain things on and turn certain things off, something's going to happen. Binary, or something else I should say about binary language, because I used to have a lot of friends that wanted to get into computer programming that I would talk to on Skype all the time, and they would always ask me for advice of where to start out in programming. And it's kind of hard for me to give that advice. To me, it's really hard to give anybody the advice of where to start out in computer programming, because everybody's a little bit different. Like for me, I started programming in computers since I was 14, and my first language was actually Java, learning from the New Boston. But I kind of, after a little while of learning with Java, I lost my taste for Java and moved on to C++ and C. And I don't know if it was because of how young I was, but I just couldn't grasp the concept of low-level memory management that you see in the C language. For some reason, that just completely went over my head. It may have been because, my mind just wasn't mature enough to be able to handle it, because it does take some intellectual to figure it out. And being, 16 at the time, I just couldn't grasp that. So then I discovered Python, and for me it was like, voila. Well, going back to what I was saying, so a lot of these people I would talk to, they'd be like, oh, so I need to learn how to program in binary. No, 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 no. I mean, you could learn to program in binary. You're not going to like it. I don't even know if it's possible. I've never even tried to look into actually writing a program in nothing but machine language. But the problem with us writing programs in machine language is, think about it. If you watch my Python programming, my Python HTTP and FTP series, you will see that I probably don't have more than 50 lines of code, and even I make mistakes. And probably most of my mistakes is that I misspell something. And it's very, very easy, especially whenever you have a couple hundred lines of code. It is very easy to misspell something. For instance, in Python, you do print hello. It's so easy to just, whenever you're focused on a program, to instead get letters mixed up. And the next thing you know, if you have a couple hundred lines of code, you're scrolling through 100 lines of code going, where is this? Where is this? And it just aggravates you unless you actually read the debugger and it told you what line it was on. So just imagine writing hundreds and hundreds of lines in ones and zeros. One, it'll take forever, because it would be, to print something out would probably take a couple hundred lines within itself, because you would literally have to be dictating what every piece of hardware is doing at the moment in a way. So we came out with programming languages to basically get away from the primitive machine language, because it just doesn't click with us as easy as it does for the machine. We don't think that way in terms of numbers and math, because it's a lot of math that goes into it. You have to think, go a little bit more into it. IPv4 addresses, you may have heard, are like 128-bit or something like that. As an example, we will use IP address 1.2.168.1.4. Each one of these segments represents a byte. A byte is 8 bits, I believe. So let's pull out the calculator. So if we have I don't know, it's been a while since I've done the calculation, but kind of lost myself here for a second. So yeah, there's just a lot of things that go into it. We don't think as mathematically as computers do right off the top of our heads, as quick as computers do. So I'm not really going to go into the whole entire binary thing. If you want to look it up, that's awesome. It's actually a pretty cool concept to kind of read about and kind of get a basic grasp of. So if you want to do that, Google it. It's great to read about. I thought it was kind of interesting. So I'm going to go do this little example thing, and I'm going to put it all into Movie Maker, combine them, and post it for you guys to read. So hope you. Alright, so I told you that I would come up with a real life example of the binary system and the whole 1 and 0 concept. Now my example's not the greatest, but it kind of gets the point across. As you can see, I'm in my office right now. Kind of interesting looking office. Yeah, the other guy who works at me with solid shell security is just jealous of it. But how we're going to demonstrate this concept fairly simply is by using this lamp. Alright, if you got a computer, you more than likely have access to a lamp. You can try this little experiment if you want to call it an experiment. So here we have a light, we have a switch. I pay my my family pay our electricity bill, so we have electricity. One thing you need is a source of electricity. So, very, very simple. We all know how to work a switch. Up is on, down is off. So think of this as up is 1, down is 0. So what happens whenever we flip the switch? The power goes out. Whenever we flip it on, power goes on. That is exactly how everything in a computer runs. You flip a switch, something's either on or off, and all of that gives us an effect, whether it be turning out a light, or we flip a series of switches and we end up getting something cool like an HTTP server. So this is my little example, kind of cheesy, I know, but it's the best example I could think of. So hope you enjoyed. Feel free to comment on our videos, register on our community blog. Have a good one.